So, as I said, I'm not here today, so I'm going to ask you to complete the quiz on Canvas for your drill. There's a link to it on the resource page, so I hope you've done that. We're going to look first of all at the symmetry that we started looking at last class. So I'm just going to finish going over that, which was 177, 9 to 13. We talked about symmetry in class, and we talked about the fact that symmetry with respect to the y-axis simply means that a function can be reflected, or the graph of a function can be reflected over the y-axis. So when you're looking at this particular function, if we were physically able to fold it on the y-axis, the right side would be on top of the left, or the left would be on top of the right. They're mirror images of one another. And so for every point xy on the graph, its reflection image over y equals x, over the y-axis, is negative xy. So if the ordered pair 2, 4 is on that graph, then based on this, negative 2, 4 also has to be. The y value stays the same, the x value changes. So we have to keep that in mind. Now, if I actually were able to physically flip this, so you can see this flipping here, and you can see that those match up. Now, we talked about here an even function, and we said that to show f of x is even, what we would have to do is start by plugging in f of negative x. So we start with f of negative x. So we're plugging f of negative x into the original function. So we have the opposite of x squared, which is positive x squared, which is exactly what we wanted to show. So because f of negative x equals x squared, which is f of x from up here, we can see that f of x is even. Now, if we wanted to test another quadratic function, so let's say we had f of x equals 3x squared minus 5x. Okay? So we want to know, is that even? So what we would do is do the same exact thing. We would plug f of negative x in. So we now have 3 times negative x squared minus 5 times negative x. When we evaluate that, we have 3 times x squared, but this time it's plus 5x. So since this is plus 5x and the original is minus 5x, that means that this is not even. Okay, so we would have a no for that one. Then we also talked about the fact that we could have symmetries of graph that are symmetric to the origin. And we said when these were symmetric to the origin, that these functions were odd. And we talked about the fact that when we have rotating about the origin 180 degrees, what happens is our x and y just switch signs. Okay, so if they were in the first quadrant and both positive, they'll now be in the third quadrant, both negative. Likewise. So they're just going to switch the sign on the x and switch the sign on the y. So you can see, if we switch this, it rotated 180 degrees. We have those corresponding points. We talked about what it meant to be odd. And in an odd function, f of x is our function. F of negative x has to equal the opposite of f of x. And we were asked to show that f of x equals x cubed is odd. So to do that, we need to know what the opposite of f of x is. So we would do the opposite of x cubed. Which would be negative x cubed. That's what we want to have f of negative x equals. So now we're going to do f of negative x, which is negative x all cubed, which is negative x cubed. And these match, right? So that means that that does in fact equal the opposite of f of x. So this function is odd. Okay? Now, just looking back, if we go back to where we did that other function, where we tested this one, right here, is that odd? Well, we know it's not even, so what we would do is to see if this was odd, is we would figure out what is the opposite of f of x. Well, the opposite of f of x is the opposite of 3x squared minus 5x. So when we distribute that, we have negative 3x squared plus 5x. These are still not the same, because this is positive 3x squared, and that's negative. So this would actually be not odd either, which means that this is not even, not odd, so it would be neither. And that's a possibility. And the last thing we didn't really talk about was the fact that you could also be symmetric to the y-axis. We didn't talk about it a lot because it's not a function if it's something symmetric to the y-axis. So we don't have to worry about that so much. Now, they want us to prove here that the square root of 36 minus x squared is symmetric to the y-axis. In other words, what they're asking us to prove is that symmetric to the y-axis means that it's even. So they want us to show that it's even, which means we are looking here and we're going to try to show that So what we're trying to show, since symmetric to the y-axis means even, is we're trying to show that f of x, which is the square root of 36 minus x squared, we want to show that f of negative x equals that same thing. So what we would do, plug in negative x. So to do f of negative x, we would have the square root of 36 minus the opposite of x all squared, which is the square root of 36 minus x squared, which is the same thing as f of x. So therefore, since f of x is even, it is symmetric to the y-axis. Then they wanted us to find out if this is even, odd, or neither. Well, when I look at my function, it looks like it's going to be odd. Okay? It looks like it's symmetric to the y-axis, excuse me, not the y-axis, to the origin. So I'm going to start by checking to see if it's odd. Now remember my definition. Odd means f of negative x equals the opposite of f of x. So I need to find what the opposite of f of x is. So I've got the opposite of the quantity x cubed minus 5x. So I distribute that. So I have a negative x cubed plus a 5x. So now what I'm going to do is substitute negative x in here. So I'm going to actually do my testing now. So I've got f of negative x, which is negative x to the third minus 5 times negative x. Well, negative x to the third is negative x to the third. Negative 5 times negative x is positive 5x. And this, in fact, does equal the opposite of f of x. So, proving it, since f of negative x equal the opposite of f of x, the function is odd. It is not because the graph suggested that it was odd. It's because we proved that it was odd. It's because we plugged in negative x. Okay? So when I rotated that around, I could see that it ended up on the same thing.